Assalamu alaikum, my dear students, friends, and viewers. In the previous lecture, we discussed the structure of an ovule or megasporangium. In that previous lecture, we discussed thoroughly the different parts of an ovule. Now, in today's lecture, we will study different types of an ovule. Actually, these types are forms of an ovule. There are 6 types. On what basis? These forms are on the basis of orientation of body of an ovule and the position of micropyle in respect to the funiculus. Botanists have classified the ovules into 6 categories or into 6 types or 6 forms. These 6 forms, we will discuss them one by one. Here we will take on the first type, that is orthotropous ovule. What is an orthotropous ovule? Orthotropous ovule, it is the first form of an ovule. Among the 6 forms, it is the first form, orthotropous. Orthotropous is sometimes also called as straight ovule. It is also called as straight ovule, or it is also called as erect ovule. Erect ovule. If we see the structure of this very ovule, we can see over here, this is micropyle, this is the chalaza, and this is funiculus of an ovule. As you are already aware about these structures of an ovule, micropyle, chalaza, and funiculus, if we observe this type of ovule, all the 3 structures, micropyle, chalaza, and funiculus, they lie in a straight line. If we draw a line over here, all the 3 will lie on this straight line. But funiculus and chalaza, they are close to each other, while as micropyle, it lies on the opposite side of funiculus. Here it is funiculus and it is micropyle. The 2 lie at 2 different poles or at 2 different ends, opposite ends. This type of ovule, it is termed as orthotropous or erect ovule. So what is orthotropous ovule? It is an ovule in which micropyle, chalaza, and funiculus lie in a straight line. That type of ovule is termed as orthotropous ovule. Okay? Now, this orthotropous, it is also termed as straight, or we can say that it is atropous ovule. It is also termed as atropous ovule. Okay? If we see this type of ovule, you can find in many plants, especially if we take the example of the plants, we can see this type of ovule in case of pinus. We can see it in case of polygonum. We can see it in cycas. We can see it in beetle. And this type of ovule, it is considered the most primitive type of an ovule. So it is the most primitive. It is the most primitive type of an ovule. The ovule is termed as orthotropous ovule. Now coming to the next type of ovule. Next type of ovule is anatropous ovule. It is anatropous ovule. Here you can see straight ovule. This is anatropous. You can see the curvature over here. It has curved. If we compare this ovule with this one, you can see this is funiculus over here. This is hilum or hilum, and this is the micropyle. Micropyle, hilum, and funiculus, they lie close to each other.
All the
They lie close to each other, while as the chalaza, it lies opposite to micropyle. Here, in this ovule, micropyle, chalaza, and funiculus, they were in a straight line. But in the next ovule, the orientation is such that funiculus, hilum, they are close, while a chalaza is opposite to the micropyle. Means that funiculus and micropyle, they have come close to each other. Here, funiculus was at this end, micropyle was at this end, but in this ovule, funiculus and micropyle, they have come close to each other. Ovule has shown such type of curvature that funiculus and micropyle have come close to each other, while as chalaza, it lies opposite to the micropyle. Plus, this type of ovule, you can see in this type of ovule there is raphe, which is the longitudinal lengthwise fusion of funiculus. This was the ovule which we discussed in our previous lecture also. So what is anatropous ovule? It is an ovule in which funiculus and micropyle, including hilum, they lie close to each other, while as chalaza, it lies opposite to the micropyle. Number second, this type of ovule has got raphe in it, and this type of ovule, it is found in 82% of angiospermic families. So this type of ovule is dominant ovule. It is found in almost 82% of angiospermic families. Now, let us write it. Anatropous ovule. It is also termed as resupinate ovule. It is another name. Resupinate ovule. Here in this ovule, the curvature is such that funiculus and micropyle are close to each other, while as chalaza lies opposite to micropyle. It has oriented 180 degree. It has oriented itself 180 degrees from this very ovule. Okay, this type of ovule is ortho, this type of ovule is ana. And example of this ovule, as it is found in maximum angiosperms, example is solanaceae. Another example of this very ovule is composite. Okay, and you have to remember that this type of ovule, it is representing, or it is present in 82% of angiospermic families. This objective has come several times in JKCT and NEET exams. In the sense, which of the following ovules is predominant in angiosperms? It is found in 82% of angiospermic families. Now, coming to the third type of ovule, that is, now the third type of ovule we have is hemitropous ovule or Its another name is hemianatropous ovule or transverse ovule. This is the third type of ovule after these two types. If you keenly observe this type of ovule, you can see it lies intermediate between the two ovules. If we study this one, it is a straight ovule. Okay.
Yes, sir.
If you study this one, it has undergone the bend or curvature up to 180 degrees. It has bended. While as you can see, it has also bended, but the bend is up to half. Bend is up to half. That is why it has not bended like this one, but the bend is just the half of anatropous. That is why it is sometimes termed as hemianatropous. If this one is straight,
Yes.
this one is fully curved, fully bent, this is bent up to the half. So this ovule, it lies intermediate between this one and this one. Okay. And you can see in this type of ovule, here it is M means micropyle, this is chalaza. Micropyle and chalaza, they will lie on a common transverse line, while as the body of the ovule, this is the body of the ovule, it lies at 90 degree angles with funiculus.
Yes.
Micropyle and chalaza, they too lie on a straight line, transverse straight line, while as if we draw a line over here, okay, and it shows this is the body of an ovule, this line, it signifies that the funiculus and the body of the ovule, they are at right angles to each other. This type of ovule is termed as hemitropous ovule. So what is hemitropous ovule? It is intermediate between these two ovules. Okay. So it is intermediate. It is intermediate between whom? Between
orthotropous
and anatropous ovules. Ortho and anatropous ovules. Number second, you can see body of an ovule. Body is at right angles with funiculus. Right angles means at 90 degrees. Okay. While as micropyle and chalaza, they lie on a straight transverse line. These two lie on a straight transverse line. This type of ovule is termed as hemitropous ovule. Example of this ovule is, it is found mostly in the family Ranunculaceae. It is found in family Ranunculaceae. So these were the first three types of ovules. Now coming to the fourth one. Now the fourth type of ovule is campylotropous ovule. It is the fourth type of an ovule. What it is? It is campylotropous ovule. Here you can see in campylotropous ovule, the body of the ovule is curved or bent, okay, so that the funiculus lies at 90 degrees, close to 90 degrees, not exact 90 degrees, means that it may lie at 89 degrees, 88 degrees, or even 91 degrees, 92 degrees with the body of an ovule. So we can say that in campylotropous ovule, the curvature is such that funiculus lies at 90 degrees with the body of an ovule, not exact 90 degrees. Okay? While as hilum micropyle, and these two structures, they come close to each other. Hilum and micropyle, they are close to each other, and because of this bending of ovule, there is no bend in the embryo sac. Embryo sac here is straight. There is no deformation in the embryo sac. Embryo sac is straight, although the ovule has bented itself. Okay. So what is campylotropous ovule? It is the ovule which is curved. It is a curved ovule. It is curved more or less at right angles to the funiculus. What is curved? Actually, body. Body of the ovule is curved more or less at right angles to the funiculus, so that hilum and micropyle lie close to each other. They lie close to each other. Stop. Campylotropous. Example of this type of ovule is capsula. Capsula and caparis. These are the two examples of campylotropous ovules. Now coming to the fifth type of ovule, that is amphitropous ovule. What is amphitropous ovule? If you see this type of ovule, here both body of an ovule is curved along with the embryo sac. It is a type of ovule in which both body as well as the embryo sac is curved. And this curved embryo sac, it resembles the horseshoe. So we can say that embryo sac over here is horseshoe shaped because of the curvature of the ovule. So in amphitropous ovule, both body and embryo sac are curved. Both are curved. Body as well as embryo sac, both are curved. Number second, you will remember over here, this embryo sac, it is horseshoe shaped. Very important point it is. Sometimes it has been asked in different competitive exams, name the ovule in which embryo sac is horseshoe shaped. So amphitropous ovule, it is the type of ovule in which embryo sac is horseshoe shaped. Why it is horseshoe shaped? It is horseshoe shaped. It is curved because of the curvature of an ovule. Okay, and you will see over here the micropyle and the hilum, they are close to each other. In this type of ovule, micropyle and hilum, they are also close to each other. This type of ovule is termed as amphitropous, and the example of amphitropous ovule is poppy. Very important plant. Poppy is example, and it is also found in some crucifers. It is found in some crucifers. So this was the fifth type of ovule, that is amphitropous ovule. Now coming to the last type of ovule, that is cercinotropous ovule. What is cercinotropous ovule? It is a type of ovule. You can see in this ovule, this is the funiculus. It has a long funiculus in it, and this funiculus covers the ovule fully. It is externally covered by the funiculus. In this type of ovule, funiculus is very large. It has a large funiculus, and this large funiculus, it covers the ovule fully. It externally covers it. It coils itself around the body of an ovule. So this type of ovule is called as cercinotropous. In cercinotropous ovule, Here, funiculus covers the body of an ovule externally. It covers it externally. It is a special type of ovule. Funiculus is very large, and this funiculus wraps around the body of an ovule. Example of this type of ovule, it is found in many plants, especially in case of opuntia. So these were the different types of ovules. So in short, we have 6 types of ovules: orthotropous, anatropous, hemitropous, campylotropous, amphitropous, and cercinotropous. Thank you for watching the videos. Hope you will subscribe the channel Arshad Botany Classes, Kulgam, for the upcoming videos. Thank